Hey everyone, welcome to This Explainer. Today, we're diving into one of the most fascinating and honestly deeply romanticized mysteries in modern tech. Does AI actually dream? I mean, think about it. When computers power down, do their neural networks just drift off, wandering through some crazy electric landscape? It's a super captivating idea. And today, we're going to break the whole thing down. We're looking at the science, the math, and the sheer computational reality behind it all.
So let's just start right there with that core question. Does AI dream? Now, the second we even ask this, we're actually doing something very specific. We are anthropomorphizing artificial intelligence, right? We're taking these deeply human terms and just slapping them onto machine behavior. But as you'll see, using human words for machine actions, well, it can be incredibly useful, but it can also be incredibly misleading.
Okay, let's dive into this. Because the very idea of an AI dreaming, it totally conjures up this surreal, almost magical aesthetic, right? Like some mystical blending of minds and planets. But there is a massive tension here between this romantic myth of the digital dream and the stark, literal mathematical reality of what is actually happening inside those server racks. To really wrap our heads around that reality, we need to completely rethink what a dream actually is.
Here's our roadmap for this explainer. We're going to start by defining the AI dream. Then we'll compare carbon versus digital substrates, look at how machines actually dream, figure out the purpose of digital dreams, compare biological versus digital dreaming, and finally, wrap up with optimization in a human costume.
Section 1. Defining the AI dream. What exactly is a dream?
Well, if we look at the standard human definition, Webster's dictionary defines dreaming as a series of thoughts, images, and feelings that happen in your mind. Now, based on this strict definition, AI just immediately fails the test, right? I mean, an artificial intelligence doesn't have a subjective mind. It absolutely doesn't have actual feelings or emotions, so if we stop right there, the answer is a hard no. But computer scientists don't stop there.
Just compare the human definition to the functional reality of AI. While we humans require thoughts and feelings, researchers define machine dreaming as, and this is a quote, autonomous processing, reinterpreting, and synthesizing of stored experience during downtime. See the difference? The AI definition focuses entirely on function and process. It completely strips away the need for any kind of subconscious or emotional experience.
Moving on to Section 2. Carbon versus digital substrates. The implementation layer.
And this brilliantly illustrates the core difference. While the big overarching goal is higher-level intelligence, the way internal phenomena like dreams are routed depends entirely on the physical layer, the substrate. For us humans, our carbon-based substrate powers a subjective experience. We feel it. For AI, the digital substrate is powered purely by computational networks. It's just math. The high-level goal of processing data is the exact same, but the implementation fundamentally different.
All right, Section 3. How machines actually dream. The core mechanics.
So researchers generally implement this digital dream in 3 distinct ways. We're going to cut right through the heavy technical jargon here and break this whole thing down into 3 super clear, digestible steps. We've got neural replay, feature extrapolation, and latent space traversal.
First up is neural replay. This is heavily used in deep reinforcement learning, like those models that master chess or learn to control robotic arms. Basically, during its downtime, the AI reaches back into its memory buffer and just pulls out random batches of past actions. It then stitches all these variables together to simulate scenarios that never actually happened in reality. It's like it's playing in a virtual sandbox, testing out hypothetical edge cases so it can learn way faster without needing to go through the slow, messy process of real-world trial and error.
Okay, the second method is feature extrapolation. This one is super famous in programs like Deep Dream. So normally, an AI looks at an image and tries to identify what's in it, right? But here, scientists run the network in reverse. They basically tell the AI, hey, whatever you think you see in this random static, enhance it. So if one little layer of the network detects a faint mathematical curve that kind of sort of resembles a dog's ear, it recursively exaggerates that feature over and over again. And suddenly, boom, the image just explodes into those wild, surrealist, fractal line patterns of dog eyes and weird limbs we've all seen.
And the third method is latent space traversal, which is what modern generative AI uses. Imagine this massive, multi-dimensional mathematical landscape where literally every concept, like metal, sadness, or cat, has a precise GPS coordinate. When the AI is generating something without rigid constraints, it's essentially taking a walk through this latent space. It drifts between coordinates, synthesizing concepts by blending features that would never exist together in the real world. It can mathematically blend the vector for glass with the vector for ocean waves. It's literally an algorithmic synthesis of everything it has ever witnessed.
Section 4. The purpose of digital dreams.
Why hallucinate at all?
Well, the reality is, real-world data is often just too slow, too expensive, or honestly too dangerous to learn from. Take a self-driving car, for instance. Instead of making a physical car drive millions of miles and crash a bunch, scientists let the AI train inside its own hallucinated world model. It runs millions of scenarios a second, asking, wait, what if the road were ice? Or what if a tire just blew out? And it does this to prevent a huge problem called overfitting. See, if an AI only trains on exact real-world data, it becomes way too rigid, too specialized, and it just breaks when something unusual happens. So by injecting this random noise during an offline dream state, the AI is actually forced to find underlying principles. It yields real, algorithmic, abstract reasoning. Pretty wild, right?
Which brings us to Section 5, Biological versus Digital Dreaming, a direct comparison.
Now, what's really interesting about this slide is when we lay out the stark differences side by side. We see that while biological dreaming is triggered by REM sleep for emotional processing, AI dreaming uses idle GPU time to prevent that overfitting we just talked about. But the absolute biggest differentiator here is awareness. Biological dreaming requires subjective experience. It requires a narrative, a feeling. Digital dreaming, it's pure computation. There is absolutely zero internal experience or self-awareness going on.
And we see this difference again when we look at how both systems actually gain insight. Think about it. When a human solves a problem in a dream, the output is this sudden conscious idea, right? An emotional aha moment. And validation happens when you wake up and test it out. But when an AI gains insight through a machine dream, the output is simply a matrix of updated weights that lower error rates. And the validation happens entirely mathematically, through a loss function that just proves the AI became a tiny bit more efficient.
Finally, Section 6, Optimization in a Human Costume.
So the crucial point here is perfectly captured in this quote from the source text. It's machine optimization wearing a human costume. Look, using a term like dreaming to describe what an AI does, it's a really handy analogy for understanding its function, but it is a terrible description of reality. Blindly using human terms without acknowledging the difference in the substrate completely obscures how the highly complex hardware and software actually work. And honestly, worse than that, it can create this false, kind of dangerous illusion of consciousness. Which leaves us with this final thought. We know AI processes information in a way that mathematically mirrors our own insight gathering. So does that mean this is a new form of intelligence? Well, the source material argues yes, it absolutely is. But the real question is, how far will we push it? Is AI just catching up to people, or is it taking its own wildly different path towards some sort of digital enlightenment? It's a completely fascinating question to ponder, but as you do, just remember, even Commander Data from Star Trek had an off switch. Anyway, thanks so much for joining me on this explainer. Keep asking those big questions, and I'll catch you on the next one.